Good evening and welcome back to the Sleep Journey. Today, we are following a quiet visitor and the strange calm that came after its pass. Most teams expected the story to soften once 3i Atlas cleared its closest point. In the early hours of December 20th, the world watched with patient focus as the object completed its nearest approach. From Chile to Japan, observatories held their gaze, waiting for the usual signs. A weakening, a fracture, a slow retreat into the outer dark. But the sky offered the opposite. Right after it slipped past the moment of closest view, it began to change. Not by slowing, not by breaking, not by shedding itself into dust. It steadied and adjusted. No sudden blast, no violent tail bloom, no drifting cloud of debris, just a sequence of small shifts, so subtle at first that you could almost miss them, and yet heavy with implication. New calculations kept replacing old ones. Course estimates updated, then updated again. Spin patterns seemed to alter. Tail features flickered, then returned, arranged differently. It looked like a response, as if something inside the object had taken the Earth encounter as a cue, and what followed strained nearly every forecast, built for ordinary comets and ordinary stones. This did not feel like a simple flyby. It felt like a signal, because calling it a comet had already become difficult. For weeks, 3i Atlas had resisted neat labels. It crossed the inner glare near the sun and did not come apart. It produced jets at angles that felt wrong and released patterned bursts, frequencies that did not read as random noise. So what moved through our neighborhood on December 20th did not feel like a typical icy body, wandering in from deep space. Some watchers used a word they almost never use, aware, not as certainty, not as an announcement, but as a tremor in the back of the mind. And when most of the world exhaled, thinking the closest point was safely behind us, the few who stayed with the data noticed something else. The object was already changing its attitude, as if it were beginning to turn. In this episode, we will move gently through what came next. The shift in motion, the quiet reordering of structure, the unexpected refusal to lose mass, and the sudden disappearance of certain lines, right before a new pattern appeared, unlike anything recorded from a known natural body. This is not a comet, simply leaving. This is a system, reorienting, and for the first time, it seemed to point somewhere else, maybe even back toward us. So, let us begin. For months, scientists had marked December 20th. Not for a launch, not for a flare, not for a scheduled reveal, but for a quiet alignment. A clean passage, a moment of geometry. An interstellar object would thread its way through the map, between Mars and Earth, with no dramatic interference. Just position, light, and time. That object was 3i Atlas. And on the morning of December 20th, it reached its closest approach to Earth. And still, it was not close the way headlines suggest. There was no impact risk. No tidal tug. Everything leading up to this had been gathering quietly. After its solar encounter in late October and early November, 3i Atlas did something the cautious models did not like. It stabilized. Instead of breaking under heat, it emerged intact. Instead of dimming on the way out, it brightened. Jets formed. An anti-tail appeared, and by the second week of December, it still carried low-level emissions. that should have faded by then. If it were a normal outbound traveler, now, at this pass, those behaviors could be measured with unusual clarity. The night before the closest point, observatories moved into coordinated focus. High-altitude sites in Chile, infrared networks in Hawaii and Japan, tracking systems stacking frames into composites. James Webb shifted for a brief, careful scan, and older orbital platforms, usually reserved for routine watch lists, were redirected for wide dust trail views. No panic, no rush, just quiet precision, and a kind of held breath. At exactly 0411 UTC, the object crossed its minimum observational arc. For 8 minutes on either side, instruments across 5 continents captured spectral bands in near-perfect overlap. And what they found, in that narrow window, was not a spectacle, not an explosion, not a blazing flare. It was controlled, almost restrained, like a mechanism finishing a maneuver and drifting past its observer. No fragmentation streak, no thermal signature of collapse, no sudden debris arcs, no frantic venting. The coma held its symmetry. Jets that had leaned slightly sunward, aligned into a cleaner cone. The anti-tail, that had confused teams for weeks, kept its shape. No diffusion, just a faint glow, curling back toward the sun. Steady, quiet, geometric. For a moment, it looked like the simplest outcome, a body gliding through the frame and continuing onward. But after that window closed, the numbers shifted. In the hours that followed, the departure vector did not match expectation. The difference was tiny. Less than a degree. Less than 0.1%. But it was enough. Enough to tell analysts. This was not just a passive object crossing our lens. Something had changed, and it seemed to happen right at the closest point. As if the object chose not to announce itself then, but still made one clear decision. It altered course. It began as a discrepancy. A few pixels. A slight offset. The kind of thing software often blames on noise. But in orbital mechanics, small errors do not politely disappear. They accumulate, and this one grew. Slowly. Silently. Beneath the threshold of casual eyes. It did not look like an impact, or a breakaway, or a sudden chaotic shove. It looked like adjustment. Just enough to raise that quiet instinct. In the people who know what to look for. The first hint came from a passive radar sweep. A set of scans, cross-checked between stations, that noticed the outbound velocity vector, no longer lined up perfectly with the inbound track. On its own, it could have been dismissed. Atmosphere, drift, calibration noise. But within hours, 2 more observatories in the southern hemisphere reported the same slight deviation. By the end of the day, 5 independent stations agreed. 3I, Atlas was not following the predicted exit path. And yes, non-gravitational acceleration is not unheard of. Other interstellar visitors showed small deviations, often tied to outgassing, or the uneven push of sunlight. Those shifts had context. They looked messy, asymmetrical, thermal. This did not. Here, the change was clean. It did not wobble. It did not wander. It curved gently, as if choosing rather than reacting. The magnitude was small, less than an arc minute. But the shape of the curve was what unsettled the analysts most, because it was coherent, across multiple scans, as if it belonged to a plan at JPL. Orbital teams reprocessed everything, ground and space tracking, stacked and cross-checked, again and again. First, they tested outgassing, the usual suspect when paths drift. But the numbers would not agree. The motion was not aligned with observed jet directions. There was no thermal pulse, no delayed push, no rotation wobble that could explain it. The energy budget did not fit. Then they tried radiation pressure. In theory, sunlight can act like a steady hand, especially on a low-mass body with large area, like a kind of photon sail. But that explanation also weakened. The object orientation did not shift enough, and solar pressure tends to create slow drift, not a gentle pivot inside a narrow span of hours. Still, the deviation remained. The first clear change appeared within 16 hours after closest approach. Noticed just after it crossed the 1 Udexen RU mark, almost as if it waited until it had passed the cleanest viewing window, and then quietly turned. The new direction was not random. It angled slightly away from both Earth and the Sun, placing it on a different outbound arc. Still hyperbolic, still escaping, but not in the way the forecasts expected. The term for this is a non-gravitational vector impulse. In natural bodies, it tends to look chaotic. In Drei Atlas, it looked balanced, and that difference, more than the size of the shift, is what started the quiet conversations. In observatory back rooms, and in late-night department halls, not because anyone knew what it meant, but because for the second time in just a few months, a visitor from another star had done something that should not be so clean. And this time, Earth was watching, and when a comet changes its motion, it is usually because of heat. Sunlight warms the surface. Ice turns directly into vapor, and escaping gas can act like a tiny engine. But what happened next did not sound like a leaky engine at all. It sounded like a decision made softly. In the dark, those earlier deviations had a story behind them. They were lopsided, messy, linked to obvious venting and slow crumbling under heat. They looked like natural recoil, the kind you expect when a surface is boiling away. But this case did not carry that same signature. The path change from 3 Atlas was clean, steady, almost straight in its intent. No jitter, no wandering drift, no chaotic wobble that could be blamed on an uneven body. It did not wander like a stressed comet. It eased into a bract, gentle curve like a deliberate correction instead of a panic response. The shift was tiny, less than an arc minute, yet the shape of it that was the part that disturbed the analysts. Because it did not look noisy, it looked designed by math. Across multiple scans, the new outbound track stayed consistent, as though a single choice had been made, and then followed calmly. A JPL Orbital teams went back through everything. Ground tracking, space-based frames, fresh reductions, new fits. They tried to recreate the deviation with familiar causes. First, the usual suspect outgassing, the quiet thrust that comes from vapor escaping and dust being dragged along. But the reconstruction would not settle into agreement. The direction of the motion did not match any known jet line. There was no thermal spike to time, the push, no delay, curve, no rotation, wobble that would smear the signature. And the energy budget did not support the maneuver. So the teams tested the next safe explanation: solar radiation pressure. In theory, sunlight can act like a constant hand, especially on a low-mass object with a broad face, like a sail, but that also fell apart under close inspection. Orientation had not shifted enough, and solar pressure tends to produce a gradual drift, not a subtle pivot inside a tight window. Still, the anomaly remained. The first dependable deviation appeared within about 16 hours after closest approach, noted soon after the object crossed roughly 19 AU. That timing felt almost intentional, as if it waited until the clearest viewing arc had passed and then changed direction gently outside the loudest attention. And the new heading was not random. It leaned away from both Earth and the Sun, placing the object on a different outward arc. Still, escaping, still unbound, still hyperbolic, but not along the expected exit line. It was as though the object had made a slight adjustment, not to stay, but to leave on its own preferred track. In Celestial mechanics. A motion like that is labeled a non-gravitational vector impulse. In ordinary natural bodies, those impulses look ragged, full of irregular recoil. In 3I Atlas, the effect looked balanced, symmetry instead of chaos, and that difference more than the size of the shift is what started the quiet conversations in observatory halls and late-night data rooms, not because anyone could name the cause, but because this was the second time in months that a visitor from the system had behaved in a way that did not feel accidental. And this time, Earth had eyes on it. To understand why it was so troubling, you have to return to the basics. When a comet releases material, it is usually because of heat. Sunlight warms, the surface ice turns into vapor, and vapor escapes through, cracks pulling dust into the flow. That process builds the familiar shapes, tails, jets, flares, ion streams, and almost all of it follows one stubborn rule. The flow moves away from the heat source, away from the sun. But on December 20th, shortly after the closest viewing point, something appeared that did not follow that rule at all. At first, it was easy to miss. In the mid-infrared channels, a concentrated jet formed near the southern quadrant of the nucleus. Not a broad haze, not a soft cloud of gas. A narrow stream tightly collimated with a steady vector and a symmetry that held frame to frame. Within minutes, telescopes in Chile and Japan confirmed the same. Feature separately, cleanly, without disagreement. It was not a glitch. But the shock came from the geometry. When teams calculated the direction, the jet was not pointing out from the shaded side, the way most models would predict. It angled back, toward the solar vector, toward the line it had come from. Jet aimed sunward. In conventional comet physics, that is nearly impossible. Sublimation depends on uneven heating, material vents from warmed surfaces, and the pressure difference pushes flow away from the sun. A sunward jet asks for something else, some form of shaping guidance or confinement, something that forces the stream to behave against the simplest gradient. So the search for explanations began. One idea was rotational. Lag. Maybe the body turned and revealed a freshly heated patch. But to match the timing, the spin would need to be fast, and earlier observations had suggested a slow rotation, possibly under one full turn every 18 hours. That pace did not line up with what the jet was doing. Another idea was surface failure. A dark crust could crack, exposing a volatile, rich layer beneath, but again the direction did not cooperate. A collapse might explain a burst, but not a stream that appears to lean into the sun against the usual thermal pressure. The natural models kept failing, not because they were weak, but because the geometry was stubborn. And then the jet became stranger. It did not vent and dissolve. It held together frame after frame. It stayed column, like stretching thousands of kilometers outward. It brightened, then leveled off as if reaching a stable output. Edges stayed clean, density looked, even the gradient smooth. This was not a spray. It read like a beam. And a beam changes the emotional weight of the data, because propulsion in its simplest form is recoil. Push mass one way, and the body shifts the other way. So if 3 Atlas needed a gentle correction away from Earth or away from the sun, a jet, aligned back along the inbound direction, would be the exact kind of impulse that could do it. Suddenly, the mystery had two matching pieces, the clean post flyby deviation in its path, and a physical stream caught in the infrared pointing in. The precise direction a maneuver would require. Not proof, not a verdict. Just a quiet alignment of clues that made the night feel colder. Because for the first time, the course change did not look like a body being pushed. It looked like a body choosing how to move. So the question settled in quietly. Was this simply an unfamiliar kind of comet activity? A hidden style of venting no one had ever recorded before? Or was it something more controlled, a thrust-like behavior? Using jets that looked natural to steer with. Precision. No one wanted to say that plainly, but inside the tracking notes, the stream received a calm but chilling description. Vector consistent direction, sunward duration active, and beneath it, one more line. Appeared. Possible navigational function. Tails are supposed to be the simple part, the easy lesson. A bright trail that always leans away from the sun, shaped by radiation, and the steady push of the solar wind. A comet tail does not follow the comet's path. It follows the sun, reliably, predictably, almost universally, until it does not. A little more than a day after 3 Atlas crossed its closest viewing point, reports began arriving from multiple sites, 2 in South America, 1 in the Canary Islands, all describing something that should not be there. At first, it sounded like noise, a calibration slip, or a faint atmospheric echo, but the confirmations kept stacking. Independent frames, independent nights, the same, geometry repeating. A new feature had formed behind the object, and it did not behave like a normal tail. It was aimed toward the sun. The anti-tail had returned. This was not the first time 3 Atlas had teased that shape. During the earlier solar encounter, a sunward pointing streak had appeared briefly. Back then it was easier to dismiss, a perspective trick. Old dust lying in the orbital plane, caught at just the right angle, making a backward line seem real. But now the arrangement had changed. Earth and the object were no longer aligned the same way. The lighting was different. The viewing angles were different. And still, the anti-tail held. A thin column, sharp and narrow, stretching in the opposite direction from what the textbooks promise. This time, it could not be waved away as a viewing illusion. The structure shimmered faintly in visible light, but it spoke more clearly in ultraviolet, where a telescope network over the Indian Ocean saw it strongest. It looked particulate, yet strangely ordered. It did not bloom outward like ordinary dust. It arranged itself into a fine line, narrow in angle, long in reach, tens of thousands of kilometers pointing back toward the sun, and, too, most unsettling detail was its steadiness. Over hours of tracking, the anti-tail kept its shape and orientation, with a stability no natural comet dust has ever shown. No gentle bending, no trailing curve, no wind-torn fraying. Just a rigid direction, as if held by an unseen framework, or resisting forces that should have scattered it immediately. Some researchers wondered if it was linked to the earlier sunward jet, an active vector, not leftover debris. If so, then the anti-tail would be more than a trail. It would be a consequence of behavior, a byproduct of directed emission or controlled output. Others reached for a different explanation: field alignment, dust suspended inside an electromagnetic structure held in place by charge and geometry. But that idea required something extraordinary, a localized field strong enough to stabilize particles across vast distance. Nothing in ordinary comet science offers that easily. Then another detail appeared along the spine of the line, small brightness changes, regular enough to notice. Pulses as if the structure had internal dynamics, not only persistence, but activity. To the teams watching in real time, this was not just an odd picture. It felt like a repeated motif, a pattern in how 3 Atlas organized itself as though it was coordinating around the sun, not merely reacting to it. In official language, the reappearance was filed under a neutral phrase, persistent anomalous structure, but, behind closed discussions, the problem sounded simpler. Direction. Because the only thing stranger than a tail pointing sunward is a sunward tail that refuses to waver. And then, without drama, no flash, no blast, no obvious spike in the monitors. A slow rise began, a gentle lift in brightness, quiet enough to slip past casual eyes, yet unmistakable when compared to baseline stacks. As 3 Atlas continued outward after the Earth passage, a new trend emerged across several bands. It was brightening. That should not happen. Comets grow brighter as they approach the sun, that is the common rhythm. More radiation, more activity, more scattering, more glow. After perihelion, the story should reverse. Less input, less outflow, less. Like comas shrink tails, thin infrared signatures, cool the body drifts outward, spent and quiet. But 3 Atlas did something else. After passing both the sun and Earth, it began a gradual increase in luminosity, seen in visible and near infrared. The first hints came from Arizona instruments, then confirmations from optical stations in Eastern Europe, and then from space-based infrared arrays within the NOAA satellite grid, all describing the same curve: slow, not spectacular, but steady. And the timing made it more uneasy. The rise began about 12 hours after the anti-tail returned. It did not match any clear solar flare cycle. It did not track a solar wind spike. It did not resemble a simple rotation-driven flicker. Instead, it looked uniform, clean, almost controlled, like a system warming up from inside rather than from the outside. So the question changed again: what was feeding the glow? Infrared thermometers showed a stable surface, temperature, no fresh jump in solar heating, no new jet activity that could explain a surge. The coma stayed calm, outgassing looked reduced, no obvious new vents, and yet the nucleus seemed to intensify, as if a reservoir beneath the crust had been switched. Some suggested delayed heat migration energy absorbed earlier, moving slowly outward through layers, but that required a very specific interior, a particular insulation profile, almost like a shell built to trap warmth and release it late. Possible, but statistically rare, and it still did not explain the clean symmetry of the curve. Other theories returned to geometry, a change in what face we were seeing, a new reflective orientation, a previously shadowed region turning toward Earth and sending back more light, but that explanation demanded a very particular body, a hollowed interior packed with light volatiles, wrapped in a shell that holds warmth like a thermos. Possible, yes, but unlikely when you weigh how often. Nature builds that exact stack of traits, and it still did not account for the most striking part, the curve itself. So smooth, so balanced, so evenly shared. Other teams tried a gentler answer rotation. Maybe a darker face had turned away and a brighter face had turned toward Earth, sending back more reflected light. But the change was not shaped like rotation. It did not rise and fall. It did not pulse. It did not shimmer in a repeating cycle. It climbed in one continuous way, like the whole object, every side we could see, had simply become brighter together. That left one comparison, not a conclusion, just a reference point. When powered satellites wake up, their brightness often steadies, not with fireworks, but with consistency. When thermal systems engage, radiators, panels, regulated surfaces, their signatures appear in predictable bands, and when a spacecraft changes how it reflects or releases energy, it does not always flash. Sometimes it just brightens. Quietly, that was the uncomfortable echo in the data. 3. Atlas did not shout. It did not break apart. It did not erupt. It was as if it turned the dial slightly higher. Observers began calling it by a soft name, the quiet ignition, a moment where something inside, natural or not, crossed a threshold. The emissions did not look like disorder. They looked like control. The glow settled right as the course change finished forming. And after that point, the trailing structure, the revised path, and the energy output all seemed to fall into a shared cadence. No obvious radio burst, no clear transmission band, no sudden spike in the chatter of space, only light, calm, light, steady light, almost deliberate light, as if the maneuver ended and the system entered a new mode. And to understand why that felt so strange, you have to remember how heat behaves out there. In a vacuum, warmth cannot ride on air. It cannot spread by breeze. It can only leave as radiation, slowly, patiently into the dark. That is why many bodies show delay. The delay has a name, thermal lag. Heat sinks into layers, and only later does it reach the surface in a way we can see. In comets, that lag is part of the story, a measured wait between sunlight and activity. But for 3 Atlas, the delay seemed absent. On December 20th, not long after the closest viewing point, telescopes began noticing a gentle but telling shift. As the object moved outward, solar input should have weakened. Activity should have softened. Jets should have relaxed. The surface should have begun its cooling slope. Instead, something else unfolded. 3 Atlas brightened not only in visible bands, but in mid-infrared, the range most tied to emitted heat. It began releasing more thermal energy precisely when cooling should have taken over. And the rise was not jagged. No burst, no sawtooth, no frantic chemical noise, just a smooth climb, a stable ramp peaking shortly after the course. Deviation was confirmed. Then it held, holding steady against a pattern comets have followed through centuries of observation. Naturally, the search for ordinary answers began immediately. Could this be perihelion heat stored below the skin finally, reaching the outer layers maybe? But the timing resisted that comfort. If it was simple storage, the change should have appeared earlier, especially during the Earth pass. Instead, the object stayed calm until after the path shifted, as if this act of turning and the rise in heat were linked. Some suggested cryovolcanic behavior, subsurface ices, melting pressures, changing a quiet internal release. But that kind of event usually leaves scars, irregular, jets, broken crust, fresh rings in the coma. None of that showed up. 3 Atlas stayed compact, clean, coherent. No messy outbursts, no stress patterns, no drifting debris field. And still the thermal output persisted. Others returned again to rotation. Maybe a warmer region rolled into view. But the rotation inferred from earlier light. Behavior and plasma oscillations looked slow, too slow to explain such a quick transition in the infrared trace. So the question sharpened. What if the object was not lagging at all? What if it was managing? The simplest reading, and the most uneasy, was this. 3 Atlas behaved as if it could regulate temperature. Not delayed reaction, but real-time adjustment, like a system that knows how much energy to take and how much to shed. Thermal regulation is not something we assign to comets, it is something we associate with engineering. Satellites use radiators, shields, phase change materials, active heat paths. They hold operating ranges. They avoid runaway heating. They respond quickly when the environment changes. That is what the curve suggested. Again and again, the thermal record showed almost no lag, a precise glow, a controlled cooling, a quick shift into a new steady level, not a gentle fade, but a step into stability as if calculated. And there was another detail quietly hidden in the infrared maps. The heat signature was not perfectly even. Sensors saw more energy along one vector than others, not the pattern of simple rotation, not the signature of a sunlit gradient. It looked more like directed release, like one face acting as a radiator, sending heat outward in a chosen arc away from the revised flight path. Natural or not, the impression was hard to avoid. 3. Atlas did not overheat. It did not cool too quickly. It did not react late. It did not lag. After the shock of that thermal behavior, teams turned to the sharpest decoding tool they have, spectroscopy. Every substance from frozen methane to metallic silicates leaves a recognizable pattern in light when warmed, when ionized, or simply when sunlight touches it. In astronomy, those patterns are not vague. They are crisp, repeatable, consistent. They let us separate water ice from stranger chemistry, cyanogen, complex hydrocarbons, and countless faint lines in between. So, what happened next felt deeply unsettling. When 3 Atlas passed Earth, dozens of observatories captured spectra across many ranges, visible ultraviolet, infrared, and even low-energy gamma channels. At first, the results resembled what had been seen weeks earlier, a mostly carbon-rich surface traced with volatiles, complex but not impossible. Then the course change settled, the thermal output shifted, and the fingerprint began to drift. At first it was subtle, small disagreements in the near, infrared peaks where none should sit missing, dips where common molecules usually carve their marks, and then within hours something sharper appeared, a new absorption. Feature clean, narrow, like a line drawn across the spectrum. Its position did not match familiar comet compounds, not organics, not silicates, not noble gases, not the usual ionized metals, and yet it repeated telescopes half a world apart. Different instruments, different skies saw the same line anchored, in place like a watermark pressed into the light. Even more disturbing, the feature did not stay fixed. Over roughly 12 hours, it slid steadily across the spectrum. Not because the object spun fast, not because it raced in some sudden way, but because the line itself seemed modulated, as if something on or within the body was changing surface behavior or altering the properties of surrounding material, actively reshaping how the object looked under analysis. We have seen a cousin of that behavior, but only in built systems. Some spacecraft use adaptive coatings materials meant to scatter or absorb certain wavelengths to reduce detection or to manage heat. They can change reflectivity sometimes in real time. A comet doing that sounds impossible, and yet the data carried a similar rhythm. When ground spectra were compared to orbital spectrographs, another oddity emerged. The ultraviolet profile, the region most tied to intense solar interaction, had been steady for days. Then it suddenly flattened. The usual markers of an irradiated body, solar absorption structure excited, hydroxyl carbon chain patterns became muted, as if the surface had turned opaque, to ultraviolet, almost like a fresh layer had formed. A change that fast would demand something dramatic, a rapid surface freeze of unusual material, or a shielding process we do not normally see in nature. And still there was no explosion, no obvious surge in outgassing, no debris, only a smooth, spectral transition that led to one hypothesis, still unconfirmed, but increasingly argued in quiet rooms. Maybe the fingerprint was not wrong, not broken, not misread. Maybe it was being deliberately scrambled, not like an error, but like masking, the way a signal can be encrypted, the way stealth disperses, radar returns. 3 Atlas, for reasons unknown, seemed to hide its signature after the Earth passed right when it changed. Of course, the universe does not usually play games with sensors, but 3 Atlas did not behave like usual matter. As the spectral puzzle deepened, attention moved outward to the ghostly cloud around the nucleus, the coma. In most comets, the coma is familiar. Sunlight warms, ices, sublimate gas, escapes dust, rides the flow. A fuzzy halo grows, sometimes huge, glowing with chemistry and scattered light. But what appeared after the Earth passed did not feel familiar at all. The coma did not simply expand or shrink. It rearranged high-resolution imaging. began to show structured turbulence inside a cloud that should have been passive. Instead of a simple fading gradient outward, it developed striations, layers, bands, shear lines, like currents in an atmosphere or streams in an exhaust plume. And that was only the beginning. Over the next 4 hours, instruments from Chilean arrays and the Japanese Hisaki satellite reported a change in coma density, but not evenly, not a general thickening. Certain regions grew denser, while other regions thinned at the same time. One hemisphere, trailing the revised orbit, appeared to compress as if something was drawing material inward instead of letting it drift away. Then came the direction of flow. Comas do not usually show focused motion. They are outward results and solar wind shaping. But Atlas Coma began moving against the expected solar flow. A strange arch formed, curving back toward the nucleus. Not diffuse, not random, dense, stable, and repeating every few minutes. Like a slow heartbeat, like an oscillation, something had changed. Picture a cloud around a moving body. Now imagine part of that cloud funneling back inward again and again. Not once, but rhythmically. That was the shape the data suggested. Except there were no engines, no obvious vents, no spinning body to explain the pulse. Just a quiet nucleus inside a moving storm, and the alignment was precise. The flow pattern lined up with the new course vector, as if the trajectory shift had triggered a structural response in the coma itself. What could cause that? The simplest guess would be surface collapse. A new vent opening, pressurized gas, finding a path, but no debris. Followed, no flash event was recorded. Instead, the coma behaved like something being managed, thickening, then thinning with timing that did not feel accidental. One scientist compared it to ion thruster plumes, low thrust, high control designed, for gradual corrections, not speed but precision. For a natural body to mimic that, it would need an internal mechanism able to generate channel and shape force, not merely vent gas, but aim it. Then spectral work added another thread. The densest regions of the coma carried a slight chemical difference. Trace ionized particles, not typical of comet outflow, including ionized nitrogen species that usually require strong electric excitation or intense localized magnetic fields. The Earth-facing side of the coma looked strangely calm, flat, dim, quiet. But the far side pulsed, arched, and seemed to swirl, and within that pattern, researchers began to sense something like a system. Not chaos, not randomness, modulation, structure, response. The coma was no longer behaving like a simple product of sunlight. It was starting to look like a controlled environment, organizing itself around 3 Atlas. It moved with a cadence that felt self-made. Its own quiet timing. Steady. Measured. As 3 Atlas drifted farther from Earth on the morning of December 20th, observers shifted their focus to what followed behind. Not the obvious dust. Not the faint, visible haze, but something deeper. Something unseen. Yet clear to anyone trained to listen for it. The magnetic wake. Anything traveling through space leaves a trace. A light fingerprint. A thin stirring of charged particles, shaped by the solar wind. Most of the time, it is only a soft shadow. Messy, quick to fade. But after the flyby, the wake from 3 Atlas did not resemble a shadow at all. It resembled a pattern, almost a signal. The first odd reading came from a cluster of CubeSats, sent out months earlier to monitor solar wind conditions. These small instruments, floating in the mid-Earth heliocentric corridor, began registering repeating magnetic irregularities, right as Atlas crossed their detection range. At first, the numbers were treated like bad data. Telemetry noise, a background hiccup, a corrupted stream. But when teams compared the results with deep space magnetometers, including those on the solar orbiter, the feature did not vanish. It lined up with uncomfortable precision across 3 instruments. And the shape was not a smooth wave, not a solar weather ripple, not a simple distortion from activity on the sun. It arrived in pieces, clean, modular, sharp spikes, evenly spaced, like footsteps moving through plasma. Each spike lasted the same amount of time. Each drop away matched the last, And most important, the spacing echoed the coma pulses recorded only hours earlier. For the first time, it looked as if the object was not only acting internally, but also shaping its surroundings in a controlled way. And the scale was enormous, too large to hold in a single easy explanation. The disturbed region stretched tens of thousands of kilometers, far beyond what a small vent or a simple outgassing episode should produce. Then came the detail that broke the familiar models. The spikes grew stronger with distance, measured farther from the object, not weaker. In normal comet physics, magnetic disruption fades like ripples on water, thinning as it spreads. But this was not thinning. It was building. One hypothesis suggested an inverted plasma structure, something like an electromagnetic bow shock, except trailing behind, not forming a head. In plasma theory, a reversal like that would need active oscillation, a push and pull engine of fields, driving the shape from within. No confirmed natural comet shows behavior like this. Even interstellar visitors like Oumuamua and 2I Borisov left no evidence of complex magnetic corridors. But Atlas appeared to be forming one, a tube of magnetically disturbed space. When satellites tried to capture the effect indirectly, another surprise surfaced. Thin bands of solar wind deflection, visible not in front, but trailing behind. These bands were not spirals, not smeared, not diffuse. They ran parallel, layered neatly, as if grooves had been pressed into the wind itself, like tracks left in air by something fast and stable. And those tracks curved. They did not simply follow the sun outflow. They bent gently, yet clearly, matching the new outbound path Atlas had taken. Inside that curvature, high-frequency bursts appeared in radio and extreme ultraviolet, each one timed to the magnetic pulses already logged. The conclusion became harder to set aside. This was not a wake left by a drifting body. It looked like a corridor being reinforced, a lane being laid down, not by chance, but with repeated structure. Some called the idea impossible, too dramatic for a comet. Others began building tests anyway, asking whether a rotating magnetic core combined with variable outgassing and directional jets could imitate the pattern. But when random natural variation was used, the models would not hold together. They could not keep the pulses coherent. They could not keep the deflection aligned. They could not explain the steady build with distance. The coherence, the directionality, the consistency, all hinted at coordination, or at least an organized interaction beyond classic comet behavior. Something remained behind Atlas now. Not debris, not lingering radiation, but a kind of template, etched into the magnetic fabric of space. For ordinary comets, jets are brief. They flare near perihelion, when heat turns surface ice into vapor, pushing dust and gas outward. Then, as the object retreats, those eruptions fade. Sometimes quickly, but with 3 Atlas, the expected decline did not arrive, and what followed made earlier activity feel like a prelude. Observers expected a gentle taper after December 20th. The close viewing point had passed. The coma had already expanded. The tail had responded to wind and gravity, and the stored warmth should have started draining away. Yet instead of softening, the jets intensified. Not in violence, in precision, in arrangement. Narrow jets appeared from new regions, one after another. They did not erupt randomly, but this curve did not match any viewing angle logic. It wrapped back, as if being swept or guided by forces near the nucleus. as if the jets were influencing it directly. More puzzling still, some jets did not look like dust or gas. Ultraviolet readings suggested highly ionized particles, reacting with solar wind, more like charged packets than simple vapor. The spectral mix shifted with it. Carbon monoxide and diatomic oxygen, once dominant, became quieter, and faint metallic ions emerged, including nickel and iron vapor, as though deeper layers were being exposed or selectively released. How could jets vary with that level of control and still remain so stable? Some theorists offered a careful idea. Perhaps Atlas was not venting in the usual way. Perhaps it was managing, that beneath an outer shell, there could be layered regions, capable of releasing not only material, but energy in measurable, trackable forms. The timing only sharpened the contradiction. Jets that strengthen after perihelion, then strengthen again after an Earth pass, do not follow thermal instinct. This did not feel like a cooling phase. It felt like a transition. And as space-based telescopes tried to image it in real time, new glow patterns gathered near the active zones. Subtle, structured, and hard to forget. The images brought a new kind of unease. Soft swirls, concentric rings, circling the active points. If you could call them nozzles at all, they formed pale cones, the kind of geometry you see around aircraft when the air itself becomes a boundary. But here, there was no air, no friction, no shock in the usual sense, only space, and interaction through fields and time, a measured release into the dark. And, with every new frame, it became harder to argue for randomness. Natural forces do not keep perfect tempo. They do not fire in matching pairs. They do not synchronize jets and then quietly smooth a rotation axis. They do not lay a magnetic trail and align themselves to it while output continues to rise. So the question sharpened. Why would 3 Atlas keep firing? Not only past perihelion, but now past Earth as well. And even more quietly, what was it aiming for next? While much of the world watched outward, following that curve beyond our orbital path, something subtle happened closer to home. Not in the sky you can see, not in the object itself, but in the invisible shell around our planet. Earth wears a magnetic sheath, a protective bubble made of force and plasma. It stretches thousands of miles sunward and trails far into the night side, forming what scientists call the magnetotail, a long comet-like extension of charged particles and field lines, drawn out by the solar wind. Most days it ripples quietly, disturbed only when the sun grows loud, and otherwise almost forgotten. But on the morning of December 20th, as 3 Atlas completed its closest passage, the magnetotail jolted. Not from the sun, not from any familiar geomagnetic trigger. Instead, a compression wave moved down the tail, like a ripple sliding along a stretched ribbon. Not violent, none of those pieces were present. The sun was calm. No flare, no burst. The solar wind moving slowly. And yet the data showed a sudden twist. A brief warping along the outer layers, as if something had brushed past from the side. So what could cause it? The only object in range, with the speed and scale to even approach that region, was 3 Atlas. And that opened a new layer of questions. If Atlas passed through the magnetotail, it would have crossed the outer magnetic lines of Earth, a region rarely touched even by spacecraft. But for the tail to shift like that, the object could not simply drift through. It would have needed to do something. emit something, a charged field, a pulse, an energetic response, enough to disturb the plasma balance, without tearing it apart. The shift was gentle, temporary, but unmistakable. And then came something stranger still. Telemetry showed a brief phase cancellation. A small section of the tail's wave pattern simply vanished. Normally, those plasma waves oscillate in expected rhythm, moving in pulses back toward Earth. But for nearly 8 seconds, the pattern went quiet, like a gap in music, where sound is replaced by silence. Then the waveform returned, but slightly offbeat, as if the rhythm had been nudged, as if a foreign frequency had overwritten the tail, briefly, and then stepped away. This was the kind of anomaly that refused dismissal. Not atmospheric, not solar, not terrestrial. It came from space, and the timing kept pointing to Atlas. So what could it mean? Was Atlas carrying a field strong enough to touch planetary-scale magnetism? Did it pass through a natural resonance pocket and trigger a reaction? Or the thought that stayed in whispers? Was it probing? Some began to say, not in headlines, but in quiet rooms, that 3 Atlas did not merely pass Earth. It touched us. Not physically, but magnetically. And in that touch, it left a fingerprint. Not in the atmosphere, not in visible light, but in the deepest invisible structure that shields life below. A magnetic echo, still ringing, after the object had already turned away. And as Atlas moved outward, something strange happened. Or rather, something did not happen. It did not dim. Usually, as a comet or interstellar body recedes, brightness falls quickly, distance increases, angles change, activity drops. Within days, many objects fade beyond all but the largest telescopes. But with 3 Atlas, the glow persisted. Not static in a simple way, not obviously artificial, just unusually steady, stable in a way natural fading curves rarely are. Instead of sloping downward, the curve flattened. For nearly 12 hours after closest approach, the magnitude held, and then lifted slightly. Not much, only enough to trouble careful eyes. That is not coma dispersal, not dust reflection, not leftover ice quietly burning off. It read like sustained output. After the moment when the object should have started slipping into invisibility, as if something inside had turned on and kept the lights low. But on deep sky arrays, including Subaru and Childs Ulmer, ran simultaneous spectral reads, trying to break the glow apart into causes. What they found was not clean, but it was not normal. No single gas signature dominated. Instead, repeating peaks appeared in near-infrared and in microwave bands, the kinds of regions that can hint at regulation, structured emission, heat being managed. And still, thermal models suggested the surface temperature had not shifted much. No spikes, no evidence of sudden internal heating, which made the steadiness feel even stranger. For brightness to hold, energy must be involved. But for the surface to remain calm, that energy would need to be redirected, channeled, converted, so it could look like reflection, even if it was not. Was this a new kind of outgassing? Or something else entirely? An interstellar object maintaining steady brightness while moving away from both Sun and Earth, without expanding, without releasing new visible material. That stretches every familiar model, Some tried a safer idea: slow rotation, a large reflective face, catching sunlight at just the right angle. But that fell apart quickly. The light curve showed no periodic rhythm, no rotation pulsing, no repeating oscillation, only a flat, unwavering glow, like a beacon set to low power. And then another trend quietly emerged: the alignment of the brightest emission. Over time, the strongest point of glow appeared to remain oriented toward Earth. Not perfectly, not like a laser, but with enough statistical weight that analysts began asking a question they did not like. Was it facing us? That possibility changed the feeling of the data, because if brightness stays steady and stays directed toward one point, it may not be passive reflection at all. It may be directional emission, or a side effect of a structure capable of directing energy. 3E Atlas was not only staying bright, it was staying bright in our direction. And as it drifted farther away, that single fact lingered. It did not vanish quickly. It seemed to watch. When something like Atlas passes close to Earth, especially after a hard solar encounter, astronomers listen closely to rotation. Spin reveals stress, hidden structure, sublimation patterns, not like a body being pushed by obvious forces, but like internal dynamics were adjusting it. Stranger still, the shifts seemed localized. Most tumbling comets flail as a whole, chaotic across their entire mass. But Atlas showed what some called node-based rotation, as though certain sections moved independently, while other parts stayed aligned, almost like internal gimbals, allowing one region to hold a lock while the rest corrected. This is not just rare, it is nearly impossible in standard models. It would require deep compartmentalization, separated mass regions, enclosed chambers, structures that do not behave like simple rock and ice. Other ideas were offered: magnetic coupling to the solar wind, jets activating late. But the data resisted them. No new clear outflows appeared in high-resolution infrared, and the movement was too slow, too measured. To be a simple recoil from venting, what stood out most was the sequence. Between each realignment, the object paused, sometimes for an hour, sometimes for several. Then it adjusted again. Slightly, consistently. Each adjustment moved its brighter face a few degrees closer toward Earth. Like calibration, not tumbling. And that is why some minds drifted toward spacecraft behavior, because this is how probes sometimes move. Slow attitude changes, holding a lock on Earth, for alignment, for transmission, for control. And that raised the hardest question. If the rotation was controlled, what was doing the controlling? There are no known natural bodies that self-regulate spin this way without clear forces acting upon them. Not unless something gyroscopic, something stabilizing, exists deep inside. Yet Atlas is supposed to be a fragment, a remnant, a traveler from light years away. So why did it begin to behave like a machine? That question triggered coordinated tracking. Japan, Chile, South Africa, Hawaii. Light curves stacked, timelines compared. And then, suddenly, the drift stopped. In one specific window, the axis froze, the alignment locked, and the object held that orientation for nearly an entire orbital segment. That is not ordinary precession. That is stabilization. Nothing in the current catalogue of interstellar objects behaves like this, especially not after a brush with Earth. It was a quiet hint that whatever 3E Atlas is, It may not be spinning freely. It may not be drifting at all. It may be operating. And the farther it moved into space, the more it began to resemble something intentional, in a way no one had prepared for. Then, only hours after the rotation freeze was confirmed, another odd report arrived. Earth-based deep radio arrays began flagging what they called an echo pulse, a faint patterned return, not sourced from Earth, not a bounce from the Moon, and not matching natural reflection behavior. It began as a single blip. At the Green Bank Observatory in West Virginia, a low-frequency spike appeared during an automated sweep of the upper orbital region. At first it was treated as interference, routine noise, a stray human signal, but then it happened again. And again. Each return arrived with the same delay window, as if reflecting from a precise point in space, and coming back like a quiet sonar ping. And the delay time matched, almost perfectly, the distance to 3 Atlas along its current track. The pulses were faint, but steady, regular, rhythmic, patterned. Every return came back on the same delay, as if the signal had touched one exact point in space and then drifted home again like a quiet sonar echo. And the timing matched almost perfectly the distance of 3 Atlas on its outbound track. Just beyond the closest pass, the pulses were faint but clear, regular, steady, patterned, not random hiss, not scattered bursts from solar wind, not the usual chatter of charged particles. The data was rushed to larger ears, to the Very Large Array in New Mexico and to the Square Kilometre Array Pathfinder in Australia. And as the checks came in, the concern deepened. There was an echo pulse linked to 3 Atlas, but it was not behaving like a plain rock return. The spectrum came back, uneven. Certain bands returned weaker than they should, others returned stronger. It was not just a passive bounce, it was interaction, as if the object were managing its cross-section the way stealth systems try to scatter and absorb detection bands. But natural bodies do not do fine filtering like that. Not with that precision, not with that consistency. The rhythm was just as unsettling, a response every 3 minutes, steady in its timing, and within that rhythm, a repeating structure, one long, one short, then another long, then a pause, then again. It was not Morse, not any familiar human format, but it was ordered, and it held, across 6 observatories, different hardware, different skies, the same pattern. If this were a comet, it would be hard to explain. No jet, no ordinary magnetic wake, no plasma ripple should produce mechanically neat replies over distances, this large with timing this exact. So the next question arrived on its own. Was 3IE Atlas reacting to Earth? Transmissions. To test it, engineers at Arecibo successor facilities sent a controlled burst aimed at the coordinates of 3 Atlas now sliding beyond Earth orbit. They waited 2 minutes, then 3, then 4, and a return appeared, faint, but present. Only this time the echo was different. The spacing widened, the phase shifted slightly, the gain changed its balance, as if the object had registered the stimulus and adjusted the reply. That did not match any familiar behavior in radar, astronomy, and it did not behave like a single instrument. Glitch, because it showed up across continents, across systems, and stayed tied to one moving target. For the first time, private conversations began circling a word many had tried not to use, since Oumuamua, intentionality. Not a declaration, not a headline, just a question that would not leave. Was the object sending, or was it built to answer? Either way, it implied complexity far beyond a tumbling interstellar fragment, and the pulses did not weaken. As the object gained distance, the clarity slowly improved. While the echoes kept arriving, the community turned back to something more visible, something that did not require a giant array to notice, because now it was happening. In open light, 3 Atlas was changing color, not a mild tint shift, not a viewing angle trick, not atmospheric scatter, a real transformation unfolding in real time. At first, observers blamed geometry, sun angle processing, but images kept arriving from different hemispheres, from amateurs and professionals alike, and the results stayed the same. The tone shifted from pale gray, the dusty look of a high reflectivity surface, to a deep emerald green centered near the core, not in the tail, not spread through the coma. It was coming from the heart of the object itself. Green is not unheard of in comets. Excited carbon can glow that way, but it is usually diffuse, uneven, and tied closely to the sun, and it does not last long. It fades as the molecules break apart. But 3 Atlas was already outbound, moving away from the sun. And still, the green core held hour by hour. It grew stronger. Spectral checks from Hawaii added another quiet shock. The green wavelengths did not match the usual carbon signature. They sat slightly lower in energy, more focused, as if passing through a filter or shaped by an optical cavity. In plain terms, the light did not feel simply reflected or casually fluoresced. It felt formed. Stranger still, the glow stayed confined. It did not bleed outward, into the tail. It did not wash through the coma. It remained anchored, locked to a single geometric region near the object's midsection, and overlays from multiple angles suggested something harder to ignore. The bright point did not rotate the way a surface patch should. It stayed aligned toward the direction of travel. Natural bodies tumble, their highlights wander, their emissions drift. This glow did not drift. So, theories began to gather. Some suggested a magnetized region, an electromagnetic lensing effect, bending particles and light into a false color. Others imagined internal crystallization, a deep layer, exposed emitting photons through exotic reactions with trapped gases. But none of it explained the steadiness, the precision, the way the glow held its shape like a boundary. Infrared imaging tried to read behind the green. Was it masking, heat a hotspot, a cold pocket, a chemical flare? The results, they were unclear, but one detail stood out. The area around the green core was warmer, yes, but only by a narrow margin. Not the kind of jump expected from runaway sublimation, almost regulated, as if temperature were being managed across a defined zone. When teams compared the new frames to photos from weeks earlier, the contrast felt unreal. The same visitor, once a dusty, frozen speck, now looked, if not mechanical, then at least built from materials that behaved like engineered systems. And just as that thought settled in, a second glow appeared on the far end of the body, faint blue, flickering like a quiet reply. A question formed, one no one wanted to say loudly. Was the object waking up? And if so, what had stirred it? And, while the world watched the colors, the astronomers had to redirect again, because something happened that forced every major observatory to shift its attention. It was not the light. It felt almost perfectly regulated, as if a steady hand were shaping the heat inside a clean boundary. When astronomers placed the new frames beside images from only weeks ago, the difference landed like a shock. The same traveler, once a dusty frozen speck, now carried the look of something precise, something built to manage light and warmth. And as that unease settled, a second glow appeared. On the far end of the body, faint blue flickering like a quiet reply. A question formed in the background. One no one wanted to give a voice. Was the object waking, and what had stirred it? While the world stared at the color, something else arrived, and it pulled every observatory in a new direction. It was not the light, not the tail, not the anti-tail, not even the blue flicker. It was something that looked solid. For days, the surface had seemed steady aside from the radiative oddities, but in the early hours of December 20th, high magnification imagery from an orbital telescope above Chile caught a new shadow, a protrusion rising from the central spine. At first it was treated as a ridge, a cracked slab ice shifting under stress, but within 2 hours that comfort failed, because the structure kept climbing frame by frame. As the object drifted outward, the height increased. Not a trick of lighting, not a change in viewing angle. It was extending evenly, methodically. No bursts, no sudden lurch. Just a rhythm, steady, deliberate, almost too consistent. Measured against the curve of the body, it looked long, narrow geometrically. Straight, it rose upright relative to the direction of travel. When it reached full visibility, the scale challenged natural guesswork. It was not a spike, not a boulder, not a plume hardened into shape. Observers began using one word because nothing else fit as well: a mast. And it did not end with one. Within minutes of the first extension, a second structure began to unfold from the same central root. This new piece rose on a diagonal linked to the first by something thin, almost translucent, yet it caught infrared light like a faint beam. Unlike the rough contours of comet terrain, this formation carried edges, straight lines, clear angles, parallel segments. Across live feeds, the same thought kept surfacing. Was it assembling something? The mast held the diagonal span, widened, and then the whole formation moved. Not the entire object, only the structure. A small pivot a few degrees toward the last known direction of Earth time. Lapse composites made it. Hard to deny, the reflective rim caught sunlight at a new angle, confirming independent motion. That should not happen, without a system capable of control. Speculation spread quietly at first, then faster. Some imagined a communications array triggered after the flyby. Others wondered about a sensor platform, a scanning arm, a listening mast. A few suggested energy collection, though no clear radiation spike followed. But one idea began to lead the room: a modular structure hidden inside the body, deploying on a timed sequence. The glow, the echo pulses, the tail behavior, the path correction, and now the unfolding hardware like geometry. It began to feel like a chain of steps, each one timed, each one responsive, not just to sunlight, not just to distance, but to Earth. The implications weighed heavily for anyone hoping the object was only strange and still inert, because what emerged did not resemble random geology. It read like infrastructure, and it carried one quiet message that settled into the data rooms. 3. Atlas was not finished. It was beginning a new phase. As teams tried to understand the structure, another optical event arrived, and it rippled through analysis rooms everywhere. It began in the tail, not the full tail, and not the earlier anti-tail, only the primary tail. The one that usually trails with momentum began to shift. Just before dawn over the Pacific, observers noticed a small split, a faint bifurcation forming inside. The plume. At first, it looked like a thin filament peeling away, like smoke in a changing breeze. That alone can happen. Comet tails sometimes braid under solar wind and charged particles. But this behaved differently. The separated stream did not fade, it strengthened. It curved inward toward the midline, then flipped sharply like a whip turning inside out. The tail began to act like two systems. One half remained trailing as expected following the outbound track, the other half starting near what observers began calling the active lobe pivoted forward, toward the sun, toward the leading edge. For a moment, the two halves formed an inverted Y, hanging in the dark, under known physics that opposition should not hold. Tails are passive. They answer forces, sunlight, particles, outgassing. They do not steer themselves. They do not choose a direction. They do not divide into competing vectors unless something deeper is shaping the flow. Theories formed quickly. One leading idea suggested internal ejection, a directed push from within, not solar pressure. But another question followed close behind. Why only one side? Why did the upper segment flip while the lower remained obedient? Infrared imaging offered a hint. The upper region where the reversal began showed pulsed thermal signatures, evenly spaced, not explosive, not ragged, rhythmic like a metronome of heat rising and falling by narrow margins. Every few seconds, it carried the feel of a cycle. The 14 correlation was hard to ignore. Each thermal crest aligned with a shift in the inverted tail. When temperature peaked, the tail surged. When it eased, the motion paused. Over time, the repeated cycle drew a curvature, then a deeper complexity, almost spiral-like as the object continued along its altered route. And there was no comfortable label for it, because nothing natural in our records has ever behaved this way. The upper zone kept pulsing, steady, measured like a quiet engine rhythm. And the tail answered it again and again, heat then motion, cooling then stillness, a pattern that felt less like weather and more like timing. The strange curve held in the data as if the object were writing a new rule in light and plasma one. Careful beat at a time, what mattered most was simple to say and hard to accept. 3 Atlas was rewriting the rulebook again, and because it had already slipped past Earth, the timing made it feel even stranger. This was no longer a tail that simply shed material. It behaved like a tool selective, segmented, purposeful. The notion that a tail could steer or encode data, or even carry a kind of outreach, used to belong to fiction, but now it hovered at the edge of the real. Not both sides, not a storm of random flares, only one portion redirected as if guided, as if Atlas was refining its next line through space. And the sequence was not finished, because while the split tail unsettled, the models what followed quieted. Rooms, the forward-turned segment began to blink, not like heat shimmer, not like turbulence, like timing, like a pattern with patience. At first, nobody panicked. Tails can shimmer for many reasons: charged dust, field, ripples, solar wind, changes camera artifacts. But this was not the usual kind of shimmer. It kept a tempo, and it stayed confined only to the reversed segment, the portion that had leaned against pressure and curled toward the direction of travel. The same section tied to those regular heat pulses, the same section that had begun drawing spiral hints in the dark. When the first flashes appeared, some observatories blamed instruments, dropped frames, responsive pixels background noise, but the blinking did not stop. It returned and returned again. Across 10 minutes, deep space scopes counted 17 events, not soft fades but clear on and off surges, each lasting a little over a second, then silence, then another set, sometimes 2, sometimes 5. Never identical in arrangement, yet always obeying one simple behavior. They arrived in clusters, then paused, then clustered again. A small team in Chile was the first to lean in. They were not comet specialists, their work lived in signal detection, exoplanet, noise background, decay pattern extraction, and when they saw the atlas blinking, they noticed the stillness between it. The gaps were steady. Between each group of flashes, the pause held nearly the same length, about 5, 6 seconds, and the group sizes fell into ranges that reminded them of binary structure. The thought felt absurd, a comet transmitting anything, but by then, absurd had become familiar. 3 Atlas had already bent expectations with path, changes with jets that pushed against the solar vector, with a tail that split and turned, and now it seemed to shape light into something ordered. The team began mapping it by hand on off 10. They tested it against known systems, Morse UTF, formats, packet structures. Then they tried a gentler assumption, not modern language, not human code, just a basic pulse map, binary groupings, mapped into simple characters by substitution. What emerged was not a sentence, not even a word. It looked like geometry. 3 short pulses, a longer pause, 1 pulse. 3 again. When laid across time, the sequence resembled a triangle, clean, balanced, equilateral in its suggestion. Other teams ran the same series and found the same kind of result. Again and again, simple shapes repeated. Not commands, not vocabulary, more like visual reasoning expressed as light over time, as if Atlas was not speaking to us but showing structure, and then it deepened. The last few groups right, before the blinking stopped, formed a nested figure, a triangle, inside a triangle. To many astronomers, that meant nothing, but to engineers and people who live in systems and models, it points to a specific idea, feedback recursion, a loop that references itself, something that can adjust, something that can respond. The team filed the report carefully. No claim of contact, no dramatic label, only a restrained phrase, intentional modulation. Most of the field resisted that wording as they should. Yet quietly a few agreed, because nothing in Comet behavior produces pulse clusters like this after a split tail, after rhythmic heat signatures, after coordinated geometry in the open dark. Some said data decay, some said coincidence, but others began to wonder in softer tones behind closed doors. Maybe Atlas was not only active, maybe it was attentive. While most eyes stayed on what could be seen, jets, tails, pulses of light, some researchers turned toward something unseen, Earth's own magnetic field. For decades, magnetometers have listened to space weather. They track flares, storms, and the small shivers that pass through our protective bubble. They are sensitive, built to notice whispers, and on the morning of December 20th, they recorded something that did not fit. It did not resemble a solar flare, not the sharp profile of a CME, not the noise of cosmic rays. Instead, a low-frequency tremor, soft, continuous, barely above the threshold, but steady enough to be real, and its direction felt wrong, not sunward, but from behind Earth's orbit, from the corridor where 3 Atlas had just traveled. At first, no one connected it. Tiny electromagnetic variations often looked like background wobble, but this one held a rhythm, returning every 7 minutes, like a slow heartbeat under the magnetic skin of the planet. And then came the second confirmation. 3 satellite arrays separated widely in space logged the same shift, not only similar amplitude, the same frequency, the same timing, the Pritex, same duration, the same profile. That is not ordinary noise. The signal did not jam communications, it did not collapse systems, but it did press gently on the outer magnetosphere, enough to produce micro-deviations within the Van Allen belts, enough to alter the field geometry by fractions of a degree, enough to trigger automated pattern alerts. One system tagged it plainly, magnetic anomaly origin unknown. Normally those tags disappear into archives, but this time, a Scandinavian institute chose to look closer. They transformed the waveform, pulled out peaks, searched harmonics, and what they saw made them pause. The structure faintly resembled the shape of Schumann resonance patterns, those natural low-frequency waves that ring between Earth's surface and ionosphere, usually tied to lightning and atmospheric activity. But the frequencies did not match, not at all. Still, the modulation carried a familiar form like a melody, played in a different key. The shape was recognizable, the source was not, and the direction still pointed back toward Atlas's path. Nothing could be declared with certainty, but the options felt unsettling. Either something traveling with Atlas had the ability to nudge Earth's magnetic field from far out in space with a controlled pulsing signature that echoed our own maps. Or, more quietly, Earth's field was responding, mirroring, answering like a loop, catching a new tone, as though something in that wake had not finished. Passing through, no agency held a press conference, but internal logs changed, persistent low-frequency echo, possibly non-terrestrial, and the story shifted again from light you can see to signals you can only feel. Then the attention moved even closer to Earth. High above the ocean, near the boundary of upper air, layers something rare unfolded over the Pacific. A jet stream segment changed direction. Meteorologists, I noticed first in live satellite flow maps, a narrow band west of S. Hawaii, several kilometers up, began to buckle. At first a kink, a slight deviation in velocity, then it stretched, spreading across nearly 1,000 miles in the upper Wind River. And then it reversed. Instead of west to east, it shifted east to west. For more than 3 hours, a section of the jet stream moved against its usual pattern. That kind of reversal is uncommon and rarely so localized. Jet streams are anchored by rotation, by temperature gradients, by pressure, contrasts high, above the surface. They meander, they pulse, they shift with seasons, but a clean inversion in a narrow corridor is almost never expected. And yet, it happened. It did not summon catastrophes. No massive storms formed immediately. Air traffic was not halted, but the models struggled. High-resolution simulations threw errors. Analysts had to strip feeds down to basics to be sure it was real. Weather balloons from ships and coastal stations confirmed it. Sensors at cruising altitude matched the satellite view closely. Upper troposphere temperatures shifted fast, several degrees within 2 hours, and the shape of the atmosphere changed Rossby waves. Elongated, stretching sideways in a pattern that felt like distortion more than weather. Someone checked the timing. The reversal began just under 6 hours after 3 Atlas crossed the near-Earth corridor, the same window as the magnetic pulse, the same morning as scattered radio irregularities near the poles, the same hours when thermal readings looked wrong above the Pacific Rim. Coincidence maybe, but this region had been steady for months. No forecast had called for an inversion, short-term or seasonal. The air mass was calm until it was not, and then as quickly as it arrived, the reversal ended. After 3 hours, the jet stream snapped back like tension releasing. Winds returned to their familiar direction. Gradients, reset models began to behave again, but the questions remained. Could a passing interstellar object contribute to upper air shifts? Could charged particles from jets or a wake couple into the ionosphere? Could Earth's upper layers sometimes respond not to oceans or climate, but to events beyond the sky? A station in Okinawa issued a quiet note, almost unbelievable in its wording. Upper-level wind inversions may correspond with electromagnetic anomalies linked to near-Earth interstellar transits. A sentence that once would have sounded impossible. Now it sat in a record, as if the air above us had briefly been asked to move the other way. Infrared satellites keep their watch always. Their purpose is plane track, heat and map Earth's thermal pulse. They see wildfires, city warmth, volcanoes, ocean shifts. But on the morning of December 20th, they logged something outside their usual stories. About 3 hours after Atlas's passage, a region of the upper stratosphere above the southern hemisphere brightened in infrared. Not a quick flash, not a single blip, a sustained glow lasting more than 9 hours. And the strangest part was not the warmth itself, it was the emptiness around it. No obvious source, no reason, no clear thing to make it warm at all. About 3 hours after 3, Atlas slipped past Earth. A patch of the upper stratosphere, high over the southern hemisphere, began to glow in infrared. Not a quick flash, not a single spike, a steady warmth, lingering for more than 9 hours. And what made it unnerving was not the heat itself, it was the absence of any clear reason for heat to be there at all. No wildfires beneath it, no volcanic plume, no known re-entry, no storm system capable of lifting energy that high. The location was almost too empty. An open stretch above the South Pacific, a wide, quiet region where cloud cover is scarce, no nearby land, no busy air corridors, a place agencies sometimes use to let old satellites fall harmlessly. But this was not the signature of something burning up. This was warmth in a layer that does not like to hold. Warmth. It began as a tight signal, clean, circular, about 150 kilometers wide. Then, slowly, it spread outward, ripple, after ripple, thermal rings, like gentle waves, not explosive, not chaotic, patterned, as if a precise amount of energy had been placed there and quietly maintained. The temperature never surged into extremes. It hovered, only 3 to 4 degrees above baseline, but it stayed there. That stillness was the part that bothered the analysts. Even solar disturbances, even debris events, tend to heat, then fall away. This did not fall away. It held. Multiple satellites verified it, not just major agencies. Even private weather networks began updating their infrared maps. Without much comment, researchers in Kyoto noted another detail. The warm patch drifted slightly eastward over open ocean without matching any surface wind patterns, as if it belonged to the upper layer alone, moving by its own rules. And then a stranger layer appeared. A Chinese research satellite, Galan 5, captured a multispectral view. In a thermal-enhanced channel, a faint distortion showed up. Not a perfect shape, not a crisp symbol, but a curved trace, subtle, trackable. It reminded some analysts of ion-tail artifacts reported near Oumuamua and other fast interstellar passes. The curve seemed to keep pace with the route Atlas was taking. As it exited the near-Earth window, it did not look like a vapor trail. It looked like leftover warmth, as though something had skimmed the atmosphere's edge without truly entering. A brush, not a plunge. And here was the problem. Anything large, enough to create that much persistent infrared energy, should have been noticed. By someone, by something. Nothing on the lists, nothing natural, nothing man-made, nothing recognized by Earth's tracking systems. So the conversation began to tilt. What if Atlas did not only pass by, but reached us? Indirectly, a jet, a stream of accelerated particles, a filament of charged material. Not an impact, not a crash, just a whispering contact at the most fragile boundary. And it left heat behind. No debris, no visible flash, no shockwave, only warmth, measurable, traceable, and slow to let go. As night spread across the Pacific, the anomaly finally began to fade, but the data stayed, and the process implications somehow felt colder than the sky that carried them. Something had touched us, with precision, not force. And while Earth tried to settle, another rule began to bend. The tail. For centuries, a comet's tail has meant one thing: flow, scatter, drift away from the sun. A symbol of motion and loose chaos. But 3 Atlas began doing something else. It started pulling its tail inward, not breaking apart, not thinning into nothing. A contraction, controlled, as if the tail were being gathered back to the core. Within 6 hours of the pass, multiple instruments, including Hubble and SOHO, marked the shape change. What had looked wide and wavering began bending toward the nucleus. At first, a few analysts blamed perspective, a parallax trick, as the viewing geometry shifted. But that explanation didn't survive, because observers far apart, Parker Solar Probe, ESA's Solar Orbiter, and Japan's Solar Watchers, all reported the same curling, from different angles. The tail wasn't merely fading with distance. It was folding, with intention, and spectroscopy made it stranger. As the tail drew inward, its chemistry changed. The familiar mix, dust, water vapor, sodium, ammonia, gave to now way to heavier behavior. More ionized material, clustered near the core, forming streamlines, like invisible filaments tugging it home. It felt like watching a storm reverse itself. And then, the glow. The more the tail retracted, the more the central body brightened in ultraviolet, and even X-ray bands. That's backward. For every standard model, comets usually weaken as they lose mass, but Atlas looked as if it gained coherence from the withdrawal, as if what it released had never been fully lost, only temporarily extended. Ground observatories in Chile and South Africa confirmed another shift. The tail stopped looking turbulent. It smoothed into a spiral, a clockwise coil, rotating along the object's axis, light traced. The inner curve, making the structure easier to see. Dust does not usually behave like that, not with that clean continuity. One Caltech researcher described it softly, less like a tail, more like a tether, being wound back in. A scientist in a quiet briefing suggested it, resembled self-regulation, not collapse, but consolidation, a gathering, as if Atlas was preparing for a second phase by bringing every loose part back into place. And then, the stillness, over. The next 2 hours, motion in the tail stopped. The spiral, the curl, the draw, it froze, mid-gesture, as if a final tension point had been reached. And at the same moment, the core signature shifted again. Not a flare, not a violent spike. A gentle change in modulation, like the tone of a beacon quietly sliding into a new setting. Atlas continued outward, but now, without a tail, without a trailing stream, just a core, centered, contained, for the first time since it arrived. It looked whole. This did not resemble unraveling, it resembled completion. We are used to comets that drift, burn, fade, and disappear. But this one did not break apart after Earth. It did not exhale its last breath. It adjusted. Maybe its intent, maybe its schedule. The movement that followed was not messy. The jets were not wild. The emissions did not feel accidental. It looked like choreography, a trajectory refined, a transformation timed. And while our world tried to breathe out, believing the closest moment had passed, something out there seemed to be preparing for what comes next. The planet will keep turning, people will sleep, headlines will drift to other stories, but the instruments, the quiet eyes in the dark, have not stopped. Listening, the signal, in one form or another, still appears active, and the object's orientation no longer feels aligned with simple physics alone. It feels aligned with observation, as if watching was never the full story. As if we were part of the equation. If this truly was only a flyby, then what follows may be the return. So tonight, as you let your breathing slow, hold the thought gently that the universe is vast, quiet, and still, full of surprises. And if you'd like to keep traveling with us through calm stories and distant skies, please take a moment to tap like and subscribe to the Sleep Journey. It helps the channel more than you'd think, and it tells YouTube to bring you more nights like this. Now, let the screens dim, let the mind soften. Good night, and I'll be here when you're ready for the next journey.